So for 2.2, there are pictures of ice, water, and lemonade on a picnic table. How do you know which liquids is in each picture? It's easy. Lemonade is yellow. It has kind of a tart taste to it and hard to miss. A yellow color and the tart taste are two properties of lemonade. So we're going to talk about physical properties of substances. So what are some examples of physical properties? A physical property is any characteristic of a material that can be observed or measured without changing the composition of the substances in the material. Viscosity, that's a fancy science word that means how thick it is. Conductivity, whether it's thermal conductivity or electrical conductivity. Malleability, can you bend it? Hardness, melting point, boiling point, and density are examples of physical properties. We're going to be doing a density lab on Friday, and we'll notice that different materials have different densities. Example of physical properties. Viscosity is the tendency of a liquid to keep from flowing. All right. Oil is very thick. It has a high viscosity. Honey is very thick. It has a high viscosity. So thick liquids such as corn syrup, honey, they have high viscosities. Thin liquids such as vinegar and water have a low viscosity. Okay. Conductivity. A material's ability to allow heat to flow is called conductivity. Materials that have a high conductivity, such as metals, are called conductors. Good conductors of heat are also usually good conductors of electricity. My research at Notre Dame, I worked on thermal conductivity during phase shifts. Okay. Malleability. The ability for a solid to be hammered without shattering is malleability. Most metals, such as gold, are malleable. In fact, gold is very malleable. It's very soft. You could literally bend it. It's almost like aluminum foil. It's such a soft metal. That's what makes it so precious, is you could do so many things with it. An ice cube or a piece of glass breaks into a million pieces if you hit it with a hammer. If I take an ice cube and hit it with a hammer, it shatters. If I take gold and I hit it with a hammer, it just bends and moves. Okay. Solids that shatter when struck are brittle and not malleable. So that's like the opposite side, right? Something that shatters is the opposite side. One material can scratch another material if it is harder than the other material. So a kitchen knife can scratch a copper sheet because the stainless steel is harder than the copper. The material used to sharpen a knife must be harder than the stainless steel. Diamond is the hardest known material. That's why when you buy a drill at Lowe's or something, you're going to cut through steel. It's usually a diamond bit. They call it, and so what they do is they take little pieces of diamond and put it into the tip of the bit because it's harder than the steel. This is a carver who's using a special type of tool to carve a canoe, and it's red cedar. Now, red cedar is a very soft wood, and his little tool there is probably made out of iron or steel, which is harder. The temperature at which a material changes a state in a physical property is a melting or boiling point. So when I did my research on thermal conductivity, I took paraffin wax, which you could buy at a grocery store, and I heated it up, and it turned into liquid. And then I heated it up a little more, and it turned into a gas. All right? So the melting point is when it goes from a solid to a liquid, and a boiling point is when it goes from a liquid to a gas. Here are some common melting and boiling points. Hydrogen. The melting point for hydrogen is very, very low. That's why it's a gas at room temperature. The boiling point is still very low. So at room temperature, it's naturally a gas. Nitrogen, very similar. But if you look at things like water, in the SI system, water freezes at 0 degrees Celsius, but it also melts at 0 degrees Celsius. So if we go a little bit colder, it freezes. If you go a little bit warmer, it turns in, it's liquid. Now, if you heat it up to 100 degrees Celsius, it will turn into steam, right, which is a gas. Table salt, you can actually melt table salt. It's got to be really hot, though, 800 degrees Celsius. Now, you can actually turn table salt into steam if you go up to about 400 or 1465 degrees Celsius. Gold, you got to melt it, it's got to be 1064 degrees Celsius. You can actually have gold vapor. So when I was at Notre Dame and I was doing research on photovoltaic cells, we actually gold plated the electrodes on the solar cells. And the way that we did that is we took little chunks of gold and we basically boiled it. And so it turned into a vapor. And then the vapor, when it cooled off, settled down. And where it fell, we had a mask. Where it fell, it left. We were basically gold plating these electrodes, or where the electrodes were supposed to be. So the electrode and counter electrode. So that's a real thing. There's a machine at Notre Dame that you put little chunks of gold in, and it literally boils the gold, turns it into a vapor, then it shuts off, and the vapor just kind of falls down. And wherever it falls, if you have a mask, it'll fall into whatever thing you want it to be. It's a very common technique, actually, not only with gold, but with other items too. And then there's a question: which substances are liquid at room temperature? You just gotta check if those temperatures fall between the melting and boiling points. The ratio of the mass of a substance to its volume is density. Yeah, here, come get this. Silver has a density of 10.5 grams per cubic centimeters. A coin with a density of 9.9 grams per cubic centimeters is not made from silver, or it contains substances in addition to silver. So if I take a copper penny and I know the density of a copper penny, and then I calculate the mass and calculate the volume, and I go through the math, and it doesn't match up with the known density for copper, then maybe they added something a little extra to pennies, right? Another metal to help the penny last longer. How can knowing the physical properties of matter be useful? Physical properties are used to identify material, to choose a material for a specific purpose, or to separate substances of a mixture. So using properties to identify materials in a variety of ways. For example, you can decide which properties to test, do test on a sample of an unknown material, and compare the results with the data reported on known materials. So one summer I did research for Northwestern, and I just collected luminescent properties of a very thin material. What did I do? I shined a light or a laser on a material and watched to see what the material did when I shined the laser on it. And that was it. We did white light studies with that too. So then, properties determine which materials are chosen for which uses. For example, shoelaces must be flexible and they must be able to bend without breaking. You could never make copper shoelaces. Copper is malleable, you can move it around, but it's not that flexible. Shoelaces need to be flexible. They must also be durable, right? And withstand repeated use. What if I tied my shoes and they were too flexible and they broke? So laces and hiking boots are usually made from nylon or leather, not from wood. That's funny. Not from wood. So what processes are used to separate mixtures? Filtration and distillation are two common separation methods. So if I take salt water, in other words, if I take water and I put salt in it, we talked about this yesterday, I think in this class or another class, how do I separate them? Well, if I boil the water turns into steam. Remember that the boiling point for salt is way higher than the boiling point for water. So if I raise the temperature of that salt water to a little bit over 100 degrees Celsius, the water will turn into steam and eventually go into the air. But the salt won't turn into steam, and it'll stay in the container. That's one way. That's called distillation. You can separate hot tea from loose tea leaves by pouring a mixture through a strainer. Filtration is a process that separates materials based on the size of their particles. A great example of this is you can, like making coffee too, right? I can take coffee, put it in a filter. Do the coffee grounds go into my coffee? No. That's kind of backwards, though. I guess that's not the best example. So these students filter or sift through dirt using a wire screen to locate small objects. So if you're trying to find gold, the chunks of gold are bigger than like the sand. So you have a thin screen. You use water. The water and the thin particles will go through the screen, and the bigger chunks remain. That's like what a filter is. Okay, I did research on that too, permeable membranes. Distillation, sometimes all the particles in a solution are small enough to pass through a filter. If I take salt water and pour it through a coffee filter, guess what? Salt water comes out the other end. I can't filter the salt out of the water. It just blends in with the molecules too much. But I can boil the water and separate it. So in the process, it separates the separation in the solution based on their boiling points. So what if I had salt and sugar water? Pour them both into the water. Sugar has a different boiling point than salt, and it has a different boiling point than water. I would probably boil out the water, and boy, that would be hard though. But anyways, that's what you do. You determine what the boiling points are, raise the temperature of it, it changes into a steam, and then you go from there. Recognizing physical changes. I know the bell's going to ring in just a second. Let me finish this up real quick. So the change in water from a liquid to a gas during the boiling phase, that's a physical change. It changes from one phase of matter to the other. During a physical change, the size and shape of the material can change, but not the composition. So when you melt something, it's still the same composition. Water is H2O, whether it's a solid, a gas, or a steam. But not all physical changes can be reversed. When you braid somebody's hair, is it reversible? Cutting the hair, it cannot be reversed. So you can unbraid somebody's hair, but once you cut their hair, they have to grow it back. And we're going to skip the assessment questions for today. All right? That's all I got.